Hello, my name is Wasim Waidani. I am in my last year of high school in Terminal G4. My majors are math and economical and social sciences. So, to solve the exercise I was given, I had to use the Pythagorean theorem as a base to create a sequence to calculate the perimeter of the inner squares of joint style. So, the Pythagorean theorem is a mathematical law that states that the sum of squares of the length of the two short sides of the right triangle is equal to the square of the length of the hypotenuse. In other words, if the short sides of a right triangle are A and B like here, and its hypotenuse C, then the square root of A squared plus B squared equals to C. So, I tried to calculate the size of the three first squares by doing the Pythagorean theorem. I divided each result by 2 to get the length of the next two sides that allow us to do the Pythagorean theorem. For example, I divided here GO by 2 to get the length of GE, GE and GN, GE and GN. Okay, so as joint style was square and both sides A and B made the same length, in this case, the Pythagorean theorem could be simplified to C equal to A times the square root of 2 here. So the sequence that I created from this formula had to take into account that each inner square had the length of the hypotenuse of a right triangle whose short sides were half the length of the outer square. I decided to express the A as U1, so the side of the first square, which is 10 centimeters. As U2 equals U1 divided by 2 times the square root of 2 here, I simplified this to U2 equals U1 times the square root of 2 divided by 2, like here. U3 will be calculated with U2 instead of U1 and U4 with U3 instead of U2 and on and on. This means that U1 plus 1 equals to U1 times the square root of 2 divided by 2, like here. Okay. For example, this equation calculates the side length of n squared, like you can see. For example, U2 equals to U1 times the square root of 2 divided by 2, and it's equal to 5 square roots of 2 here, which is the same result that I find by making the Pythagorean theorem for the second square here. So I then multiply this result by 4 to get the perimeter of the second square, which make 20 square root of 2 here. So if I give U1 the value of 40 centimeter, its perimeter instead of 10, a single side, then the equation calculates directly the perimeter of n squared instead of its side, like here. As UN is a geometric sequence with a common ratio of Q equals to the square root of 2 divided by 2, and whose first term U1 equals to 40, then u1 equals to u1 times q to the power n minus 1. In other words, u1 equals to 30 times the square root of 2 divided by 2 to the power n minus 1, like here. This means that the first square had a perimeter of 40 centimeters, the second square of 20 times the square root of 2 centimeters, and the third square 20 centimeters, like I found here. The perimeter of the 10th square equals to 40 times the square root of 2 divided by 2 to the 9th power, which can simplify to 5 times the square root of 2 divided by 4, like I found here. Okay, so to get the total length of the black line used to mark the first 10 squares, I add the perimeter of the 10th square here. I find 132.3 centimeters. I can also use the following formula. Sn equal this formula. Sn equal u1 times 1 minus the square root of 2 to the power of 10 divided by 1 minus the square root of 2. I find the same result here, 132.3 centimeters. I enjoyed the exercise. I found it mentally challenging and I needed to think hard about the equation, but once I calculated the perimeters of the first 5 squares, I finally understood the logic behind, and I became eager to write down the formula. I was even more excited when I noticed that I could change the formula to calculate directly the perimeter of the squares instead of just the side. So I'm happy I was able to answer to those questions. Please let me know if you need any further explanation. Thank you.